Hello, this is Dr. Michael Hassan, the Engineering Doctor, and this is lecture number 33, the T flip-flop of Chapter 6, flip-flops of the course Digital Logic Design, Digital Systems, or Digital Electronics. This is a disclaimer for you to read. I cite 3 references. However, there are many books in digital logic design. The contents of Chapter 6 include sequential networks, memory elements, the SR latch and flip-flop, the clocked SR flip-flop, the JK flip-flop, and today we'll talk about the T-type flip-flop. The T flip-flop, T stands for toggle. Flip-flop has one input denoted T and 2 outputs denoted Q and Q prime. The flip-flop has 2 distinct states defined by the logic values of Q, state 0 when Q is equals to 0, and state 1 when Q equals to 1. The T flip-flop remains in one state indefinitely until it is directed by the input signal T and or the clock to do otherwise. The T flip-flop, figure A, shows a JK flip-flop converted to T flip-flop. When J is equals to K is equals to T, we will have really a T-type flip-flop. If T is equals to 1, then Q plus will be equals to Q prime. That is, the next state is the complement of the present state. And hence the T flip-flop acts as toggle switch, changing state with each clock pulse. The logic symbol of the T flip-flop is given in figure B, where I show you this is a T flip-flop with a preset and clear. And the preset and the clear, they are active flow. It means if they are ones, they are inactive, or if they are open circuit, also they will be inactive. So I have the T input and I have the clock pulse for a negative age triggered flip-flop with 2 outputs Q and Q prime. And Q prime always is the complement Q. The truth table of the T flip-flop is shown in figure C, and the compact truth table is shown in figure D. If T is 0 and Q is 0, Q plus is 0. If T is 0 and Q is 1, Q plus is 1. If T is 1 and Q is 0, Q plus is 1. And if T is 1 and Q is 1, Q plus is 0. And this is really came from the JK flip-flop, because the characteristic equation of the JK flip-flop, Q plus JQ prime or K prime Q or K prime Q. Now, replace this when this will be equal to, when T equals to J is equals to K. If you go to the characteristic equation, Q plus will be equal to T Q prime or T prime Q. Now, this is the characteristic equation of the T flip-flop. So Q plus will be 2 Q prime, T Q prime, or T prime Q. And this is, it means T exclusive or Q. Now, this is really proven in this truth table, because if T is 0, 0 exclusive or 0 is 0, 0 exclusive 1 is 1, 1 exclusive or 0 is 1, and 1 exclusive or 1 is 0. So by definition, T is, again, by definition, T is equal to J equals to K. The characteristic equation of the JK flip-flop has been proven to be Q plus is equal to J Q prime or K prime Q. Replace K and J to T, convert them to T, so the characteristic equation will be Q plus T Q prime or T prime Q, or T exclusive or Q. And T exclusive or Q, you will get Q plus as shown in truth table figure C. Now, the compact truth table, we see that if T is 0, the output, if T is 0, the output will follow the input. So Q plus will be equals to Q. If t is 1, you will get the complement. So if q is 0, q plus will be 1. If q is 1, q plus will be 0. So the compact truth table, t is 0, q plus is equal to t is 1, q plus will be equal to q prime, which is very clear from truth table in C. Based on this table, the transition between 0 to 0, we can establish the characteristic equation. Just we talked about the characteristic equation. Q plus will be equal to TQ prime or TQ, which is equal to T exclusive or Q. Now also the transition from this table, the transition from a Q to Q plus, 0 to 0, we need T has to be 0. 0 to 1, we need T to be 1. 1 to 0, we need T to be 1 to 0, we need T to be 1. And 1 to 1, transition 1 to 1, we need T to be 0. So this is what we will get. We will get the excitation requirements table. So QQ plus 0 to 0, we need T0, 0 to 1, we need T1, 1 to 0, we need T to be 1, and 1 to 1, we need 0. As actually, this is very true because this is very correct. If Q plus equal to T exclusive for Q, T will be Q exclusive Q plus, and this is what happened here. Because 0 exclusive of 0 is 0, 0 exclusive of 1 will be T1, 1 exclusive of 0 is 1, and 1 exclusive of 1 is 0. Now the state graph for the T flip-flop, we have two stable states, 1 0 when Q is 0 and 1 is 1. Now, and the value of T, when we transition from 0 to 0 to state 0, it means we are remaining in state 0. Although we are remaining in state 0 and T is 0. 0 to 1, okay, we need T to be 1. Now, if we remain in 1 to 1, we need T to be 0. And if we go back to state 0, we need 2 to be 1. So 1 to 0, we need T to be 1, as you see in the table, in the excitation requirement table. With this, we found the detailed truth table of the T flip-flop, the characteristic equation of this flop, the logic diagram flip-flop, and the logic diagram with JK flip-flop, and the logic diagram, the logic symbol of the T flip-flop. And also, we found the excitation requirements table, and as I said, the state graph. Now, if you look at the timing diagram, based on the value of T at the negative edge, of the clock, Q will change accordingly. Initially, Q was 0. At the negative edge, will go to 1 because T was 1. Okay, it's because Q plus is equal to T exclusive for the Q, which is 0, which is 1. So Q plus 1. So you see here 1. At the other negative edge, okay, we see that T is still 1. So again, Q plus at this case will be T exclusive or the previous state, which is Q1 exclusive or 1. It is 0, so Q plus went to 0. And so on and so forth. We test at the next edge. It's 0 because T is 0. So 0 exclusive or 0 at this edge here. At the last edge, T is 0 at this time, and 0 exclusive for 0 is 0, and this is what the value of Q plus, which is the next state. So as you can see, Q changed accordingly, and this is the quite simple timing diagram based on assumption that we made for T and the initial value of Q. This is the last slide of this wonderful flip-flop, the T flip-flop. And I would like to thank you so much for listening. Please subscribe, and hopefully to see you very soon. Sincerely, Dr. Hassan.